All right, so I think we just started the webinar and attendees are rolling in, which is very exciting. So welcome to our webinar today, where we're going to take a look at the Advanced Assembly Extension for Creo. And on the call today, taking us through this this journey is Zach Carson, who is a pre-sales technical specialist with PTC and a distant relative of the great Johnny Carson. Hi-oh. So
true fact.
True fact. Excellent. Who doesn't love Johnny?
Exactly.
I grew up a big fan of the Tonight Show. It was like a big deal when my mom would let me stay up a little later just to watch his monologue. And he's one of the few people in entertainment history that were funnier when they were bombing than when they were actually telling jokes. So anyway, Zach's gonna give us a brief demonstration, give us about I think it's a 10-minute presentation overview of the Advanced Assembly Extension. Then we're gonna do about a 10-minute demo. And this is pretty quick stuff. This is just to say, hey, here's what it is, here's what it can do. And if you want to see more, we might be able to show you some more today, or we can set up a more customized demo at another time, whatever makes sense for you. But also on our panel today is Paul Dye, also from PTC. And we also have Jeff Gavio, our Director of Marketing, and Bill Stickney, our Technology Director, who is also very familiar with the Advanced Assembly Extension and what it can do for top-down design and skeleton models, which kind of takes a while to demo, but we can actually discuss a bit about it. So without further ado, Zach, why don't you take us into AAX land?
Sounds good, Rob. Thanks for the intro. It's nice to be here for everybody. If you have any questions, we're just going to roll through it, but feel free to just put them in the chat or something, and then we'll answer them at the end. So you can see my screen. We'll go ahead and get started. We're going to be talking about the Advanced Assembly Extension within Creo. So what it does is it uses top-down assembly design to simplify the design, management, and then sharing of large assemblies. So quick agenda for today. First, we'll just talk about challenges we see commonly in the industry. Then we'll go into our solution to those challenges, which is AAX. After that, we'll discuss the capabilities and then jump into the demo itself within Creo and just finish off discussing some value it can bring. So some of the challenges we see companies commonly running into within large assemblies, you're always going to have multiple people, teams of people, and they need to work together. They need to be able to share information efficiently, but we need to be able to control that information. We don't want two people to be working on the same thing, stomping on each other. And the more complex the assembly, the more lost productivity if you don't have control of that concurrent design process. Now, some of these teams might even be outside your company, partner companies or suppliers, and they need information to make sure what they're doing is matching what you're doing. But you may not want to share all of your IP with outside companies. So we need to secure it, but still give them the information they need. Now, next, traditional CAD is really limited. It's predicated on building parts, building assemblies, putting it all together, bottom-up design. When you start to have a lot of users and teams working on the same things, you really need dedicated tools to do that. And things are really going to slow down if you're not using an advanced system for this. It can be very tedious to share things, to do the assembly process, to document the things that you need to do on the shop floor. PTC's solution to these challenges is Creo Advanced Assembly. And this gives you the tools to speed assembly design and then streamline the flow of information among your design team, people outside your design team, all the way down to people in manufacturing. Now, all of that sounds great, but how do we actually achieve it? Well, we start with top-down design. We plan the framework of how everything is going to go together and what it's going to look like. We might use things like skeleton models to capture pieces of graphical and geometrical information that say, this is your boundary, you work inside here. Here's the different pieces you want to look at. And we need to be able to control the reference viewer, to be able to look at the model and only focus on the pieces that we care about, but understand how all of the pieces go together. We also need control over that, okay, to define the best practices so your models are the most flexible over time, the most flexible for any changes, and you don't get anything that interferes with anything else. There's also the issue of concurrent design, and that's very similar, but the idea is now we're going to work together and we're going to share data with each other. I'm going to say, here's the outline, you do this, someone else does this, here's the things that you need to know about. This is all about collaboration. We'll use things like skeleton models, like inheritance models for pieces that need to be used in other pieces and really support that concurrent design process. We also need to work with assembly configuration. When we're dealing with things like interchange groups, whether it's fasteners, attachments, that are all going in the same way, I shouldn't have to spend time doing each one individually. Assembling each one, aligning each one. This process needs to be faster, needs to be easier. If you have a fitting, make it mount, pick the face it goes on, and select the location. It doesn't need to be complicated. And you need to be able to swap things out, do design to order. You can have a standard configuration, but if you get a custom order, you need to be able to easily swap these 5 pieces for the 5 pieces you want. And you may never build those, but you're ready for that new configuration for the customer at any time. We want to be able to define process planning. How does this thing go together? Well, we need graphics, we need bill of materials, we need everything in manufacturing to show how everything goes together. And we want to work it from the engineering information. We don't want to recreate. Advanced Assembly allows you to do that sort of process planning. We also have tools for visualization and performance management. I mentioned before, you've got a pretty big assembly. It's a lot of data for your computer to crunch. Let's give you the tools to control that, to say, I only want to look in this area, to look at this part, turn everything else off. Even just to see something as a shrink wrap and reduce the time it takes to load it up and work with it. It's a hugely valuable feature when you're working with complex assemblies. So all of these are capabilities of Creo Advanced Assembly. Now, before we jump into the demonstration, Rob, I don't know if there's anything you want to add or if there's any questions we have right now.
No questions to this point. I didn't know if Bill wanted to add anything.
Not at this point. This is a high-level overview, and it's quite good. So we should get into some detail now.
Sounds good. All
There
right.
we go.
So now can everyone see Creo?
We can.
All right. So today
The train model.
Yeah, it's a big old model.
Do this in SolidWorks.
Yeah, good luck. So we're going to be working with this advanced assembly of a train. Now, obviously, anything remotely close to a train is a pretty big model. Tons of pieces, tons of geometry, tons of work from start to finish. And advanced assembly is all about managing all of that, keeping track of your team, who's working on what specific geometry, who's working on this area. That's what AAX is for. Now, a lot of AAX revolves around the skeleton model. Lines, arcs, curves, surfaces, anything that you need to set the overall control of your model. And the idea is, once you have the skeleton model, you can go in and select these surfaces, select these curves, and so on. And then I'm going to publish them. I want to use them for working on the different structural components in this case. So I'll just name this for structure after I selected a few of those arcs or curves. And then I might even, within the same skeleton model, publish other geometry. Let's say I want to grab maybe the surface over here, the side skirt, just whatever makes sense. Any curves, lines, arcs, points, whatever references you want to make that you want to use downstream, that would make it easier for you. So in this case, we're going to be working on the interior. So I grabbed a few of these here. And then I can just go ahead and name them for interior. So now they're nice and organized. We'll know exactly what that published geometry is related to. Now I've gotten my skeleton set up. I've got my published geometry. Let's go into my structural model. And within my structural subassembly, I have my skeleton model. So from here, I can just grab the published geometry that we just made and put that inside of my structural skeleton that I have for my car structure. And same sort of thing here for the interior. Here's my interior assembly. going to go copy the geometry that we had before, in this case, the one that we called for interior. And now I've got those components basically fed down to my skeleton models. So let's go ahead and just open up the structure. And the key here is now I can work on the structure model. Somebody else can be working on the interior, and we're not stomping on each other. But we're controlled because that skeleton, everything is coming down from that skeleton that's at the top level. So in my case here, let's say I need to build out some more of this frame, maybe a support hoop for the structure. Well, I can just use the curve that's already there. We'll just do a quick, nice and easy sweep of this shape to show you how this would work. Sweep it along the curve that we have. And now we have our stiffening beam. From there, I can just say I want to cut this out where the upper support structure goes. Maybe shell it out to a different extrusion shape, whatever you want to do. At this point, it's just some standard Creo work right here. But the idea is the master overall shape is controlled by that top level skeleton geometry. That's what advanced assembly is all about, making it easy to make connections, to control them. And then as we'll see here, as we go on through this demo, to change them. So now my one support structure I made looks good. We'll just apply it to the rest of them here. So now I've got my new hoops and they're set to the master geometry. So at this point, I'll go ahead and turn everything on, turn on all of my structural assembly. And you'll see I'm using representations. So maybe I don't need everything. I don't need to see all of this part or that part. I can just turn them off, avoid clutter, visually not even worry about them. Next, we're going to be working on the interior here. So maybe I need to build a wall or some other piece. In this case, I'm going to use the existing wall and we'll just punch it out where this window is. In Creo, we have a really easy way to do this. Let's just use the published geometry from the skeleton. I'll just say, grab that loop, just select the curve there. We'll make a form feature out of it. And I'll assume this is sheet metal. So it's punched out. Go ahead and extend it and then give it a taper, give it some extra thickness. And it really doesn't matter how much I extend this out because I'm just going to trim it based on that same surface that we copied from the master model. It's right here, working with a sketch form, comes out further than we need. Let's go ahead and cut it down. And that's the outside perimeter. And again, I borrowed that geometry. I let the master control it, but I used it here inside my work. And I don't have to have the whole train. If I'm just working on the interior, that's all I have to work on. I don't have to load up all of the other geometry, have this, monstrosity that I'm working with and viewing all at the same time. And that's confusing because there's so much there. And also it really slows down the process. It takes time whenever you're working with these huge assemblies just to rotate around and let all of the geometry load. It's time consuming. So if you don't have to look at all that, don't just hide it. Just look at what you need to. So now I applied that window to the rest of my walls. My walls look good. Everybody now can see outside of the train. We'll go ahead and turn all this back on, and then we're ready to move forward. Save it off real quick, and it looks pretty good. So next, we'll go back to the top level here. And if you're working in the top level, maybe you'll set the lower levels to representations that are simpler. Maybe it's a graphical representation or whatever you need. So at this point, we're going to start working on the doors. And the same sort of thing here. We have the skeleton model inside of my door assembly. I also have a shrink wrap of the geometry. So I need to work on my doors. And I don't need to see the rest of the model, but I don't want to necessarily, or I need to see the rest of the model, but I don't want to necessarily work with the rest of it. So what I can do is bring things down like the shrink wrap of the existing floor and then just work around it. So in this case, let's go ahead and take this copy geometry and we'll say that we want to control it. So whenever a change occurs, rather than having it update automatically, we'll have it update manually, and you'll see that in action here in a second. So here, let's use that surface feature that we copied from the skeleton, and we'll make a door out of it. First, just give it some thickness. Now we'll give it some windows. Cut that out. And this is going to be a big sheet metal part, so let's go ahead and shell it out too. Looks good. And then we can just turn on the rest of the door so you can see where I'm going with this. what it actually looks like. And now I've got my door structure. And remember, this was originally defined from the master model that is controlling all of this, from that master skeleton model. Okay, so let's just turn everything back on here. Save it, set it to the master representation. And that looks pretty good. So again, Advanced Assembly allows me to copy geometry. It allows me to set up skeletons to control everything. We can use different representations to show us what we care about, what we're working on. And that's really what you have to do to work on any sort of models that are of this complexity. Otherwise, there's just too much in front of you to work efficiently. So next, what I want to do is we're going to do a little exploring. We're going to play some what if with this. I've set this model up to be controlled. So let's try and change some things. And to do that, I'm going to use the design exploration extension. Okay, this is a module in Windchill that keeps track of what you're doing through checkpoints that you set up anytime you make a change. And then if you like the change, you can keep them. If not, just revert back to a previous checkpoint. In my case, go back to the master skeleton. And this is what we built everything from, if you remember. And maybe somewhere along the way, down in the design process, we decided, I don't like how wide this is at the bottom. I want to thin this out, bring that profile in. Well, if I do that and change the skeleton, look at what happens. We'll click to update. And now there's over 800 features that are going to regenerate based off of that change we made to the skeleton model. So basically here, everything has changed because so many things were defined from that skeleton. But if you look, we have a notification here. So let's look at one thing that didn't change. It's the doors. Because a second ago or a minute ago, we told them specifically, we said that I want these doors to be associated to the skeleton, but I don't want them to update automatically. I want to tell them when to update, but I want to get the notification. So here we can investigate this. We can leave these as is, or we can start to look at the doors and see, what's going to happen if we do update it, or do we like, the change that's happened? We want to go forward with this. Well, now because of that manual update with notification, we have control over that. Then we can even look at the differences between the original version and what it's going to update to. So I can say, do I like these changes? Do I not? And if I do, I just update them. Okay, so as you can see, it doesn't have to just be everything update and regenerate. We can put specific controls on given areas that you want to do more than just update. And then using the design exploration extension, I could just create a checkpoint there. It's a point I might end up having to come back to later on down the line, and then you can just keep moving forward. Next, we're going to go into the passenger car. And let's say I want to make a change to something like the armrest. We can, go in there, make a change, just do standard Creo work. While we're doing all of this, Dex is essentially watching us. It's allowing me to say, I like this change. I don't like that change. And if I don't, then I can just go back to a previous checkpoint, to that point in time. In this case, changing my armrest. I add a feature, reorient it, we can reset it. And then using tools like Dex, I can look at what happened and see if I like it enough to keep it. And if I do, we'll just create another checkpoint and then keep moving forward. And the idea here is you can explore your model. It's going to help, innovation. We can try new things on our model. And if you don't like them, don't keep it. You're not doing a save as or making new names in different files. At any point, I can say, this isn't the direction that I want to go. Let's go back to a previous checkpoint. Let's go back to this point in time and pick it up from there again. And I can either leave it as is or make different changes. Okay, so here we created a second checkpoint, but let's say, well, we don't like where we went with that. I can go back to that original checkpoint, that shell change, and activate it. So that's the first checkpoint we created. And notice what happens. The seats are going to go back to the way they were. And that's going to be true for any sort of Creo change that you make using Dex, whether it's adding parts, deleting parts, changing geometry. If you like this checkpoint, you want to move forward with this, done. Go ahead and do it. And all of this is controlled through Advanced Assembly Extension. It really lets you work on large assemblies fast, efficiently, and in control of everything. If you don't want something to update, you tell it, I'll update it manually. Or if you want everything to do it automatically, then whenever you make a change, you can update and everything is going to change automatically and the model's going to work. So here I turned everything back on. This is our finished product. This is our train. So that's the Creo's Advanced Assembly Extension. You've gotten to see it in action. I do have a few more points I'd like to share to summarize what it can do for you back in the PowerPoint. But before that, anyone, Rob, do you have anything to add? Or are there any questions?
I have no questions at this time. I'll defer to Bill to see if there's anything he'd like to add. Actually, the one thing I want to say about Design Exploration Extension is that is a tremendous tool that is in the base model of Creo Parametric, or the base license of Creo Parametric, Creo Design Essentials. And if you need any assistance using it or getting introduced to it or figuring it out, we can help you. So, just respond to the email that we sent and we can absolutely get you in the right direction in using this tremendous tool. Because like I said, Advanced Assembly is an extension, but that Design Exploration is something that's in the base license of Creo. And I think it's something that's largely overlooked. Bill, anything to add?
Yeah, the ability to use the publish and copy pair is extremely important in top-down design. Basically, what we're doing is allowing you to do or to use external references in a nice orderly fashion. If I have something I think is external, I know where it came from because it came from a copy. I can trace it back real easily, find its source, and make changes. If you don't do it that way, you wind up with a very disorderly assembly. It's hard to make any changes to, the point of being unreliable. So this is what facilitates the external references in the top down. It's neat stuff. Very important is just the ability to trace things back to their source, and it does it nicely. So I am a big fan of this, and it's generally used in conjunction with skeletons. And the reason you do that is so we can now bring in a higher level object to make changes without having to bring the full assembly in. There's performance issues for doing that, but also if you're working in Windchill, you do not have to check out the full assembly. You can only check out the part you need. And this also one of the things that facilitates multiple people working on the model at the same time. So it's really concurrent engineering tools, really. Maybe that's what we should call them, but they work good. It's one of the best modules you can get, actually.
Mm-hmm.
That's what I have.
Thanks, Bill. We'll go ahead and finish this up then back in the PowerPoint.
Sounds good.
All right, so I just wanted to finish this off, just summarizing some value that Advanced Assembly can provide you. So it's all about improving your company's work. Specifically, it starts with reducing time to market. If you can all work together in a streamlined product development system, you're going to get products to the market faster, much faster. They're going to be better quality. You're not going to get into those situations where the design phase goes okay, and then it gets out to the shop floor, someone goes to put it together and then finds out this isn't going to work. And I can tell you from experience in a previous job, I saw this happen all the time. And a lot of times, it's a snowball effect, and it's very expensive to basically to address those challenges. You have a lot of rework. There's a lot of time that gets wasted, a lot of money that gets wasted, and AX can go a long way in preventing that. And it really happens a lot with suppliers. And you don't want to get into those situations and then look back and realize, if I just had better communication and better collaboration, that could have been avoided. Avoiding it gives you more time to spend focusing on quality and focusing on the innovation of your products. When you put those together, you're developing and defining new markets. You're trying new versions, new variations of what you've already done, if it's something that's controlled and in a tool that eliminates errors. And that's Creo's Advanced Assembly Extension. So now that you've gotten to see the entire demonstration, Rob, Bill, anything you want to add, or are there any questions?
Bill?
I don't have anything new to add. I was hoping we'd get questions.
No questions in the queue, but I think you did a great job, Zach. I think the presentation was, was to the point, and so was the demo. I mean, you could spend a lot of time on this stuff, really getting into the weeds of how you do skeleton models and top-down design, and this is a great collaboration tool. You can get into a lot with that, but I think this, you gave a very, very good overview, very informative. So thank you and great job. So if anybody thinks of any questions, or if you need anything, feel free to just respond to the email inviting you to this webinar, and we can help you out. If you're a 3HTI customer, we give you a minimum of 2 hours of desk side coaching, where we will basically help you with anything regarding Creo, with, like I said before, design exploration extensions in the base package. If you want to know more about it, we can, give you 2 hours of assistance and, showing you what it does and how it can apply to your business, and how you can take advantage of tools like that and other things that are in your license of Creo that you may or may not know about. So I guess that's going to wrap it up for today. And I want to thank our panel, Bill Stickney, Paul Dye, and Jeff Gavio, and specifically Zach for doing a great job with the demo, and absolutely to our audience for being on today. Thank you, everyone. That's going to conclude our webinar. Have a great week. Have a great weekend. And we will see you next week for our next Creo webinar. Take care, everyone.
Thanks, everyone. Have a good one.